welcome back my dear friends, students and participants for this course under NPTEL MOOC, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember, and sorry if I repeat because that keeps the general flow of the discussion much more fluid and logical. So, there are three main topics under this 30 hours 60 lectures course, each week having 5 lectures. So, the three main topics, one is forecasting, second one is regression, third one is time series. So, we are in the time series analysis, which is the last part of this course. This is week 11 and lecture 55. So, with this we will end lecture the week 11 and start from the next day when you come for the see the videos, it will be the last week, which is the 12th week. What is the coverage? Coverage will be introduction, examples, invertible concept, what is the property, non-invertible, causality, partial autocorrelation functions, all related to time series. If you remember in the last lecture, which was the 54th, I had just started about discussing about the time series specifically with respect to financial data, and I said that considering the returns as well as the price, and returns being three concepts, one is basically R1, R2, small r1, small r2 and capital R, we will try to plot the graphs. So, here is the Excel sheet again. So, this is the Excel sheet which we had, and I said that I have only mentioned it verbally what I mean by small r1, small r2 and capital R. So, the closing price for the Bajaj stock is given, and we had shown that the data. So, I will first show the data based on the prices only, these are the closing prices. They may not be accurate, they are not adjusted, but I am just giving a snapshot with considering that I have been able to collect the data from the NSE, or you can utilize Yahoo Finance also, that there you will get a lot of data for BSE and the NSE. So, this is the plot. See, if I plot that line diagram, the line diagram looks like this. I would not erase the diagram for reasons, even though I have planned a lot of things in this lecture, but I thought that I will show you the graphs which will give you a lot of idea about how the graphs behave, and then come to the ARIMA process later on. So, I will not delete the graph, I will come to that. So, I should move the graph up, so that as I do the data analysis, the graph would also be visible. I should take the graph. So, should be able to move. Let me check it's should paste it here in the front. Give me few minutes or few seconds, because if I do that, it will be much easier for me to discuss as I change the data rather than scrolling up and down. So, if I spend some time now, so the work would be much simpler for me to explain and much easier for all of us to understand. So, I am still stuck in May, as you can see in column AI, and it's not moving. Anyway, let me do the analysis because it's taking too much of time to move the graph up. Let me check if I can move it. Yes, it is happening much better. Yes, I have it. Sorry for wasting few minutes. So, I will just hide the date because that not important. Now, coming back to R1. So, R1 is, if I zoom in, you will understand, and I write the formulas accordingly also. So, R1 is basically the ratio of P2 by P1 and P1, P2 are basically the prices. So, P1 value would be the price of today, P2 will be the values of price of 1 day later. So, here the ratio would be P2 by P1 basically means the ratio of the price of the day yes for. So, it basically the 3rd January to 2012 divided by the price of 2nd January 2012. So, I will copy it later on, but first let me do. And what is R2? Now, if you remember time series specifically for stock prices or any financial data is continuously compounded. So, if you are aware, I will just write it. This is nothing to do with the course as such, but it will definitely give you a lot of information. So, generally we know if price is P2 for today and P1 is for 1 day before, considering time the time difference is 1 day. So, we know 1 plus R where R is basically the continuous the simple interest rate, and if I consider the number of days is 1. So, it will be 1 by 365 considering I am converting into year, and this R is per annum interest rate. Now, if I have for 1 year, so R is basically for per annum again, but the time difference now is P2 and P1 are for 1 year difference. So, obviously, it will be 1 plus R to the power 1 because that is 1 year. Now, in case if you are doing it compounding m number of times in a year, so the formula would be this. If you are doing it for say for example, t number of years, not 1 year. So, this becomes t, this 1 becomes t. Now, in the case when you have this concept of m becoming infinite continuous compounding happening, this becomes equal to P2 is equal to e to the power r suffix c. Suffix c is basically the continuous compounding interest rate into t. Now, based on this formula, that small r2 which is given in column AL will be calculated, and that is a very basic tenets of finance which I am just utilizing. This is just again I am saying for the information for how to calculate R2, may not be directly related for this course, but for time series concept where financial data is there, this is important. So, I will remove these because the concept would be immediately applicable in the Excel sheet. So, you can understand that. So, I have removed it. So, now comes the R2 calculation. So, that would be now if you remember the equation was, let me write it, sorry so if I write it P2 is equal to P1 e to the power r suffix c t, then obviously, in this case P2 by P1 and T is basically 1 for 1 day. So, that would become ln of this R c would be this. This is very simple, because if this is an exponential part, you are taking the logarithmic conversion, just changing it. And here remember, again I am mentioning T is 1 for 1 day. So, I should delete it. Based on that, I will do the calculation. So, this would be ln Neperian log with base e. So, P 2 minus P divided by P 1, sorry. And what is capital R? Capital R is basically the ratio of here let me check. Let me check. Okay, I did one thing. So, this part small r 1, my mistake, small r 1 would be the ratio of P 2 minus P 1 in the numerator, my apologies. And the denominator part remains P 1. So, this is if you see the values in column A j, it is 1451.1, which is for 3rd January 2012 minus 2nd January 2012 in the numerator divided by 2nd January 2012, that will give you small r 1. And if I consider small r 2, it is ln of P 2 by P 1, and capital R is total return is just P 2 by P 1. So, the denominator remains same, the numerator is now not the difference of P 2 minus P 1, it is P 2 only. So, this is now I calculate the values. I just copy this formula. So, here I have, and let me take all these 3 values. So, obviously, I will remove the closing price which is given in column A j, because it is quite large, and the other values of small r 1, small r 2 and capital R are in the decimal of 0.00 or maximum value of 1. So, this value has to be removed, this is because related to the actual price, and that we had drawn. So, if you see these are, and this is capital this series 4 is basically the capital R. So, I will remove this also. It looks haphazard. So, I think I will go there to the actual data. So, if I have, so I will basically take small r 1. So, if you check as it changes, this is small r 1 value, and in the long run, if I consider if there is non-stationarity, stationary process, the error terms which I have would basically have the mean value is 0 and a constant variance, which will try to replicate using simulation. This is for small r 2, there is not much of a change, and this is for capital R 2. So, capital R and the mean values, if I find, I am finding out the mean values, mean, and I am finding the variance, because if you remember the concept of stationarity and all these things. So, mean value would be average, I am only talking about the mean for the returns. See, the mean values are very interestingly almost 0, even though the values are very less. So, actually they should be 0. If I consider the variance, let me see, var p. So, considering the population is there, var p so and this variance will be marked with the cells being green for better highlighting, because these values I will save when the Excel sheet is drawn. So, the variability is also low for the returns. Now, coming back, so based on that we will later on plot the ARIMA P, D, Q models. We have done, we will do it for the price, then we will do it for the returns also. So, this is the part which was promised in the 54th lecture at the fag end. So, we have completed it. Let us go back to the slides. So, sorry I took a detour in order to basically explain how the returns specifically would be calculated, because they will be utilized for the time series, specifically for the financial data. So, the coverage would be examples, invertibility, non-invertibility, causality, partial autocorrelation. I will see that. So, continuing with the ARIMA 1-1 process, properties continued. So, it will be ARIMA 1-1 is invertible if the error can be represented in terms of the actual time series based on the lags which you will have. So, if you remember the concept of seasonality concept, which is in a way type of lag, because that will be keep repeating itself. Lag would basically which time frame based on which you do the maximum amount of prediction. So, here the error term. So, this error t would basically be given by the time series x t minus. Now, if you remember, phi and theta are the corresponding parameters, or the not p d q. P d q are the parameters based on how many times you will take phi, how many times you will take theta. So, phi and theta are the corresponding parameters for the ARIMA and the moving average. And here you are basically trying to sum it up based on the weighted sum of the time series, where the weights are based on the ARIMA concept. So, AR1, AR2, AR3 depending on time frames of p you are taking. If theta is greater than 1, mod of that between. So, ARIMA 1-1 is non-invertible in the sense that z can be represented in the terms of x s depending on the value of s. So, based on the lags you are trying to basically predict later on or before that. So, in invertible you can find it for lags less, you can express the error terms. If it is non-invertible, so you have to basically consider the errors are to be expressed for with using the values of x t or values later than the lag. So, for an ARIMA P Q process, even though in the general it is P D Q. So, in general, to make our life simple for the discussion, we are considering the P Q process. Now, it will be stationary if for every t, and we have mentioned that in the case that if I consider this equation, this is the same equation which we had where x t had. So, there is a stationary concept, which means the value of the rate of change of the mean value would rate of change with respect to time would be 0. So, this mean value mu was there, considering that there is a trend or an average rate. So, if I put this mean value in red, let me use a different color. So, this is the mean, and this is equal to, there is a plus, and the terms were like this. So, if I use, it was phi 1 x t minus 1, and it goes on till phi p. P is basically the number of ARIMA terms you are going to take, the parameter. So, x t minus p. So, I am following a convention of the coloring system, let it be there. So, the terms in the blue are corresponding to the ARIMA terms. The dark blue one is basically the corresponding to the mean value part. And the last term we had used a negative sign. So, I will use a minus, that was basically depending on the convention which you have. So, you will have the third set of terms, and I will use a different color, consider this orange. So, that was theta 1 epsilon 1 plus, so the minus sign I am taking outside, plus theta q, again q is basically for the moving average, epsilon t minus q, t minus q. Now, if you see the one which you have written and the one which is explained here are exactly the same, but the idea is the stationary concept being true, because the mean value mu is not being considered. So, here also again the error terms are white noise with 0 mean sigma square, and there is a polynomial in concept with respect to the errors. So, if I consider with respect to the errors, there would be a polynomial with respect to the theta 1 for the errors, and there is a polynomial with respect to the phi values with respect to the time series data. So, and the polynomials theta z and phi z have no common factors, and phi z can be represented as depending on, and this basically on the linear filtration concepts, that will be 1 minus phi 1 z, and it continues till phi p, again p is the parameter z to the power p, and theta is given, theta z is given as 1 plus. So, the sign conventions has to be considered 1 plus theta 1 z till theta q z, again q is the parameter. The process x t is an ARIMA p q process with mean z if x of mean mu, if x t minus mu is an ARIMA p q process, and it would mean that the concept of stationarity would basically mean the mean value is coming, but the terms related to the ARIMA p terms and for the moving average q terms remain as it is. So, basically that the later factors which I have written down in the bracket are more to do with the standard deviation. Now, when I am coming to the standard deviation, let me illustrate this also in the Excel sheet. This I have done, and I will try to utilize some of the fundamental principles here. I will only consider, so this column A j is which related to the closing price are based on the stochastic process, simple stochastic process, while the returns are much more easy to handle, considering they would have a distribution. And let me plot the distribution, if I remember correctly I have shown that, but let me plot the distribution. Now, by the way, the graph which you see are related to the general time series, they are not related to the distribution, just how they pan out with respect to time. So, I am going to draw a different graph related to the distribution. Yes, this is the distribution, let me take it. Yes, I have been able to shift it at one go without wasting much time. So, this is the distribution part. So, if I consider graph 1, which I will make it as, because both the colors being blue. So, it would be much easier for doing differentiation of the coloring. So, the time series are given in red, while the plot of the distribution I will consider some other color. let me consider, say for example, violet. So, it will be contrasting with red. So, this is the distribution of small r. Now, if I want to check the distribution of small r 2, it will almost be the same. So, let us go there, almost the same, there is no change. If I want to check the distribution for capital R, let us guess it will almost be the same, there is no change. So, normal is coming, but if I try to draw the distribution of the closing price, it would not be the normal distribution. It would not be normal distribution. So, it definitely it will be some other distribution depending on how the stochastic process pans up. Now, here in order to make it, because I can change the bin size, if I make it a little bit, I should increase the bin size. So, you see here how the distribution will look like. Again normal, normal and normal, they are exactly the same as here. Now, here if you see the mean values which was quoted below, the light blue one and the variability are exactly what you can find out from the normal distributions here. So, that was important fact which was related to the the time series, the emphasis which I am placing in the financial time series, that will give you a lot of information. So, now if I consider the mean value, as I said for the generation. So, here I will plot the graph, let it be. So, I will basically shift the one with respect to R 2. So, R 2 is basically ln of P 2 by P 1, and I will mark, let me mark it rather than R 2, let me mark it as this as small r 1 estimate, because we will estimate that. This is R 2 estimate and this is capital R estimate based on the distribution of the error. So, if you remember, we are considering the error term, even though it is not directly related to time series, but I will just generate the errors. Now, if you remember the concept which you have used in the forecasting, let me go back to the forecasting and consider. So, first let me write the norm inverse between 0 and 1. So, what I am taking is the normal distribution values. So, norm inverse R A and D. So, these are the values which I am generating. So, if you remember, the white noise is with a mean value of 0 and a standard deviation and keeping it fixed at as 1. So, I should add these values here. So, I am adding the value of the R, let me take it R 1. So, R 1 I add. So, if I generate these values, so I will be generating many data points accordingly. So, let me do it in this way. So, the next value would be based on generating from the data. So, if I consider the same data which was there, actually I am generating from there. So, this is basically the generated data with where the errors have been added. So, let me check how the for R 1 if this was the distribution, how would the estimated R 1 would look like? So, this would not if you generate, because considering the normal distribution it will come out to be normal, because you are adding and subtracting the error terms which are normal distribution, even though it does not look like this here, because this is just a sample. So, if I keep repeating it for infinite set of observation with many samples, in the long run it will be such. And obviously, the error term here is with the mean value 0, but and also the correspondingly the variance is also 1. But in the time series concept, the variance will keep changing depending on the concept that it is not stationary. So, how would you generate that? We will come back to that later on in the last week or the 12th week. So, with this I will end this 11th week class, which is the 55th one, and thank you very much for your attention, and we will continue more discussions. And the simulation part, if you remember, I will only stick to the Excel sheet which I had mentioned time and again. Thank you very much, and have a nice day.